Good morning, afternoon, or evening, cats and dogs. Today's video comes from the Solving Equations with Variables on each side with Grouping Symbols guided notes. So we're going to practice solving equations that contain grouping symbols and frequently variables on each side as well. So we're going to start off with example 1 that was in your notes, which is already done for you. So in number 1, we have 2 and then in parentheses 6m minus 1 equals 8m. The first thing I did do, which you can do this either as your first step or do it after you use the distributive property, but I did add the opposite where we have subtracting 1. So I rewrote that as plus a negative 1. Then I use the distributive property to get rid of those grouping symbols. So I'm going to take 2 times 6m, which is 12m, and 2 times negative 1, which is negative 2. Now you might end up having 12m minus 2 if you don't add the opposite, and then it's a good idea to write that as 12m plus negative 2. Now, if you recall, if we have variables on both sides, normally I would move the smaller variable expression, which is 8m, since 8 is smaller than 12. However, 8m is already by itself, so I do suggest moving this positive 12m to the opposite side. Since it's positive, I'm going to subtract 12m from both sides. So that gets rid of it on the left-hand side, leaving me with negative 2. And then 8 minus 12 gets me negative 4m. So we have negative 2 equals negative 4m. It's a one-step equation from this point. We'll divide both sides by negative 4. Negative 2 divided by negative 4 gets us a positive 1/2 or 0.5. You can write your answer as a decimal or as a fraction. So let's take a look at number 2. Number 1 was already done for you, but in number 2, we have to work through this one. So work through it step by step with us. The first thing we want to do is get rid of the parentheses by distributing the 2 into the parentheses on the left-hand side and the 5 into the parentheses on the right-hand side. So 2 times s is going to get us 2s. 2 times 11, whoops, my apologies. 2 times 11 is 22. 5 times s is going to get us 5s. 5 times 2 is 10. You don't have to rewrite the equation again. I just started with that as I went to go through my work. Now, at this point, we just have an equation with variables on both sides. So let's follow the steps we did in our last lesson. We've got a 2s and a 5s. 2s is smaller, so I suggest you move that to the other side. Since it's positive, we're going to subtract 2s from both sides. That will get us 22 equals 5s minus 2s, which is 3s, plus 10. Now we just have a two-step equation. So at this point, I just solve it like I do any other two-step equation. I'm going to subtract 10 from both sides. 22 minus 10 is going to get us 12, so we have 12 equals 3s. My last step is to divide both sides by 3. 12 divided by 3 gets us a solution of 4. You're going to notice that most of these examples, your answer is going to be a whole number or an integer. We're going to try to keep things pretty easy with this first set of problems that we're taking a look at. But again, s equals 4. If you want to check your solution, you can replace s with 4 on both sides. So 4 plus 11 is 15. 15 times 2 is 30. If you replace s with 4 on the right-hand side, 4 plus 2 is 6. 6 times 5 is also going to get us 30. All right, let's go ahead and move on to number 3. Don't forget, if you need to pause the video at any point to jot these things down, feel free to do that. All right, so number 3, we have the distributive property on one side, not both. So let's go ahead and start with this one. We're going to distribute this 2. Whoops, I got to get my little loopy loops there. Distribute my 2 into the parentheses. So we're going to take 2 times y and 2 times 3. So we have 7y minus 1 equals 2y plus 6, since 2 times 3 is 6, minus 2. The next thing I did was I combined some like terms on that right-hand side. So I have 6 minus 2 here. Let me go ahead and highlight that. Yeah, I've got 6 minus 2 on this right-hand side, and if you want to write that as 6 plus negative 2, that's fine too. That gives us 4. So 6 minus 2 became 4 here. Now it just looks like, I always like to simplify it before I go to solve it. So a variable and a constant, variable and a constant. So I have 7y minus 1 and 2y plus 4. I do suggest moving the 2y since it's smaller, and I would always move the variables first instead of the numbers. It just makes life a little bit easier. So 7y minus 2y is 5y minus 1, which you can also write as plus a negative 1, equals 4. Just bring this 4 down. My next step is to add 1 to both sides. That's the inverse of subtracting 1. We just have a two-step equation here. So we'll add 1 to both sides. That's going to get us 5y equals 5. Divide both sides by 5, and my solution is y equals 1. Again, trying to keep most of the answers being whole numbers or integers, nothing too crazy, but you may end up with some decimals or fractions every now and then, like we did with number 1. All right, let's go ahead and move to number 4. So I really want to stress that you want to make sure to distribute first. Do not add 1 and 2 together. A lot of times students see 1 plus 2 and they're like, I know that. I'm going to do 1 plus 2. That gets me 3. But you have to get rid of those parentheses first. So you're going to see that here. That we're going to distribute right away. I'm going to go ahead and put my little loopy loops in here. So we're going to take 2 times b and 2 times 6. We're also going to have 5 times b and 5 times 1, or negative 1 if you choose to add the opposite right off the bat. So I've got 1 plus 2b from 2 times b plus 12, which is 2 times 6, equals 5b minus 5. The next step I did was I did choose to simplify and add the opposite all in the same step. So I combine my 1 and my 12, my two constants that are on the same side together. You can't combine it with this 5 or negative 5 over here since it's on the opposite side. But I did add 1 and 12 together to get 13, and I rewrote minus 5 as plus a negative 5. Again, as you get more experience, you may not need to add the opposite every time, but it's a pretty good idea since this is the first time you're seeing these types of equations. Now at this point I have a 2b and a 5b. I suggest moving the 2b since it's smaller. It's not always going to be 2 times the variable. It just happened to be for so many of these questions. It's a positive 2b, so I'm going to subtract 2b from both sides. That's going to leave us with 13 on the left. 5b minus 2b is 3b, so I have 3b plus negative 5. The inverse of adding negative 5 is to add a positive 5 to both sides. 13 plus 5 is 18, so we get 18 equals 3b. Divide both sides by 3, and our final solution will be b equals 6. Make sure you have that jotted down. All right, let's take a look at our next type of question. So in number 5, we've got 2 and then in parentheses 3d plus 7 equals 5 plus 6d. If we distribute this 2 into the parentheses, 2 times 3d is 6d, and 2 times 7 is 14. So we have 6d plus 14 equals 5 plus 6d. You have a 6d on both sides. Neither is bigger, neither is smaller. They're both positive, so we subtract 6d from both sides. But guess what happens? 6d minus 6d cancels out, leaves you with 14 on the left. 6d minus 6d cancels out over here, and we're left with 5 on the right-hand side. And no variable. So d is not 14, it's not 5. What we have is a statement that is not true. 14 does not equal 5. If that happens, if your variable cancels out and you end up with a statement that is not true, we say that there is no solution. That means there's no possible value for d that we can plug in on both sides of that equation that will make this equation true, that will make both sides equal to each other. Or if we consider a balance, we would make this equation balanced. So there's no value that will make that true. So you can either write no solution, or you can use this symbol, which is a 0 with a slash through it, or a circle with a slash through it. It also means that there's no possible solution to that equation. So let's try one of these together here. So number 6, we have 2 and then in parentheses x minus 1 equals 4 plus 2x. So let's distribute that 2 into the parentheses. We're going to take 2 times x and 2 times 1. So we'll have 2x minus 2 equals 4 plus 2x. I did add the opposite in the next step. I've got a 2x on both sides, and they're both positives. So we'll subtract 2x from both sides. That's going to leave us with negative 2 on the left-hand side, positive 4 on the right-hand side. It is also not true. So since this is not true, we can say that there is no solution. And again, that means there's no possible value for x that will make that equation true. You need to make sure that you write no solution or the 0 with a slash through it, something to indicate that there is no possible solution to this equation. All right, let's go ahead and take a look at number 7. This one's also done for you. You can see that I added the opposite as my first step, and then I'm going to distribute this negative 2 into the parentheses. Negative 2 times x is negative 2x. Negative 2 times negative 1, once we add the opposite, is positive 2. So I have negative 2x plus 2 on the left-hand side, 2 plus negative 2x on the right-hand side. Each side has a negative 2x, so neither is bigger, neither is smaller, but they are negatives. So I'm going to add 2x to both sides, and that means they cancel out on each side of this equation. We're left with 2 equals 2. Now this is different than the last problem because this statement is true. 2 does equal 2. Does it have to be 2 equals 2? No. You could, depending on the equation, end up with 5 equals 5, x equals x, 4x equals 4x, negative 6 equals negative 6. But if you get a statement that is true, we don't say no solution. It's actually quite the opposite, in fact. We say that the solution is all real numbers, meaning all numbers are possible solutions for this equation. It could be decimals, it could be fractions. So if I plugged in x equals 1/2 on both sides of this equation, the two sides would equal each other. If I replaced my x's with 2 2/3, both sides of the equation would equal each other. If I replace both sides of my equation, the x's, with 4.6 repeating, then both sides of the equation would equal each other. So all real numbers are solutions to these kinds of equations. Now you might be wondering, what about real numbers? Are there unreal numbers? Believe it or not, there's something called imaginary numbers, something you'll talk about when you get into Algebra 2. I promise it's not made up. So when we talk about the real number system, that doesn't include what we would consider imaginary numbers, which again, sounds like I'm making that up, right? All right, let's take a look at question number 8. So we are going to start by distributing this 2 into the parentheses. So we do 2 times x and 2 times 2. So 2 times x is going to be 2x minus 2 times 2, which is 4, plus 3 equals 2x minus 1. I did add the opposite in my next step before I simplify, and I do strongly suggest simplifying before you go to solve it. It just makes things a little easier. So we have negative 4 plus 3 here. When I combine those two constants together, that gets me negative 1. So I have 2x plus negative 1 equals 2x plus negative 1. Since I have a 2x on each side, and they're both positives, I'm going to subtract 2x from both sides. That's going to leave me with negative 1 equals negative 1, which is certainly a true statement. So we can say that our solution is all real numbers. All right, I did put together some independent practice for you to try, so go ahead and pause the video, give these 2 questions a try, and when you're ready, restart the video and we'll take a look at these solutions. I can tell you that one of these will give you an all real numbers or no solution kind of solution. That's a little repetitive there. All right, so for our first question, we're going to start by distributing the 5 into the parentheses here. So I'm going to take 5 times 2a and 5 times 3 to start. So 5 times 2a is going to get us 10a, and 5 times 3 is going to get us 15. So we have 10a plus 15 equals 4a plus 9. We've got a 10a on the left and a 4a on the right. I bet you miss having 2 a's or 2 x's constantly. 4a is smaller, though, and it's positive, so I'm going to subtract 4a from both sides. Again, this is not the only way to do this problem. There are other ways as well, but I think it's the most straightforward and easiest way to find our solution. 10a minus 4a gets us 6a plus 15 equals 9. Now it's just a 2-step equation. Let's get rid of this plus 15. The inverse is to subtract 15 from both sides. That's going to get us 6a equals negative 6. 9 minus 15 is negative 6. Divide both sides by 6. Negative 6 divided by 6 is negative 1. So our final solution should be a equals negative 1. All right, let's take a look at the other independent practice problem, number 2, or the one on the right-hand side. So we are going to distribute the 6 into the parentheses and the 2 into the parentheses. So we're going to do 6 times y, 6 times 5, 2 times 10, and 2 times 3y. So that's going to get us 6y minus 30 equals 20 plus 6y. I did in my next step add the opposite and wrote 6y plus negative 30 equals 20 plus 6y. You have a 6y on each side, and they're both positive, so let's subtract 6y from both sides. We end up with negative 30 equals positive 20. That statement is not true. It's not y equals negative 30 or y equals 20. It's an untrue statement, which means that there is no solution to this equation. All right, let's take a look at some reminders here about true and false statements, then go right into some word problems. So just a reminder that if you get a true statement, such as 5 equals 5 or x equals x, then the solution is all real numbers, meaning that any number will be a solution to the equation. However, if you get a false statement, such as -1 equals 2 or even -6 equals +6, that's untrue, then the solution is no solution, meaning that no possible number will make the equation true. All right, let's take a look at numbers 9 and 10. Oops, looks like I forgot to cover up one of these spaces here. Not that it's a big deal. We'll do that quickly. All right, let's read through number 9. It says, under Plan A, an annual membership costs $30 plus $1.50 for each DVD rental. Man, it's been a while since we've used those. I guess it would now be streaming services, right? Under Plan B, the annual membership costs $12 plus $3 for each DVD rental. Write and solve an equation to determine what number of DVD rentals results in the same yearly cost. The word same in this case means that we want to set these two expressions that we're going to write in a moment equal to each other. We want the two costs for each plan to be equal. Again, same indicates equal. First thing I want to do is define a variable. It's been a while since we did that, but we are trying to determine the number of DVD rentals that results in the same yearly cost. So I define D to be the number of DVD rentals. Now we have two different plans here. This is going to happen in our next handful of questions. We have Plan A. Plan A is $30 and $1.50 per DVD rental. So that's $30 for the base cost plus $1.50 D. The D goes with the $1.50 because it's $1.50 for each DVD rental, and D represents the number of DVD rentals. Plan B, it's $12 plus $3 for each DVD rental. We can represent that as 12 plus 3D. And again, if we want the cost to be the same, we set them equal to each other. So we'll write 30 plus $1.50 D equals 12 plus 3D. No need to distribute here. We've got $1.50 D and 3D. $1.50 D is smaller, so let's subtract $1.50 D from both sides. To get 30 equals 12 plus $1.50 D. That's from 3 minus $1.50. Now let's subtract 12 from both sides to get rid of that constant. That's going to get us 18 equals $1.50 D. Finally, we'll divide both sides by $1.50, or just 1.5 also works. 18 divided by 1.5 is going to get us D equals 12. That means that if you have 12 DVD rentals, you'll have the same cost for Plan A and Plan B. All right, let's go ahead and take a look at number 10. Redbird Cruises charges $85 per day plus a one-time fee of $75 for taxes and gratuities. Remember, gratuities are just tips. King Cruises charges $100 per day plus a fee of $30. Write and solve an equation to determine for what number of days the cruise companies charge the same amount. So we are trying to determine the number of days the cruise companies charge the same amount. Same indicates we're going to set them equal to each other. So first thing first, let's go ahead and define a variable. So I'm going to let D equal the number of days. Since we're trying to determine the number of days the cruise companies charge the same amount. Let's start with Redbird Cruises. We know they charge $85 and a one-time fee of $75 for taxes and gratuities, so $85 per day. So that would be 85D plus 75. I probably should have put those separate, but 85D plus 75. And then we have King Cruises, and they charge $100 per day, which is 100D, plus an extra fee of $30. So that's 100D plus 30. Again, if you're unsure which number to put the variable with, remember that your variable represents the number of days. That's the importance of defining our variable. And since it says $85 per day, the D goes with the 85. Since it says $100 per day, the D goes with the 100. Now we've got an 85D and a 100D. 85D is smaller, it's positive, so let's subtract 85D from both sides. That's going to get us 75 equals 15D plus 30. The inverse of adding 30 is to subtract 30 from both sides. That gets us 45 equals 15D. We will divide both sides by 15. You can already see the solution there. 45 divided by 15 is going to get us 3. So that means in a 3-day period, both of those cruise companies are going to charge the same amount. Now, something to keep in mind is if you're trying to figure out which is the better deal, if you travel for more than 3 days or less than 3 days, you would want to consider what the cost is per day. So this $100 per day, if you're going to travel for more days, that's going to be more expensive, whereas the 85D plus 75 would be less expensive. If you're going to travel, I don't know why you would cruise for less than 3 days, but if you're going to cruise for a smaller number of days, then this 85D plus 75 would actually be a better deal. It would cost less, even though you have that higher upfront cost. All right, let's try one more of these. That's number 11. One cell phone carrier charges $26.50 a month plus 15 cents per text message sent or received, which I know is not the case anymore, but we'll just go with it. Another carrier charges $14.50 a month and 25 cents per text message sent or received. Write and solve an equation to determine the number of text messages sent or received in 1 month for which the cost of the plans is the same. So again, we're trying to determine the number of text messages sent or received in a 1-month period for which the cost will be the same. So my variable, I chose T. You can choose a different variable if you want, but I let T equal the number of text messages. So we'll start with our first cell phone carrier, which is $26.50 per month and 15 cents per text message. Keep in mind, T represents the number of text messages, so the T is going to go with the 0.15. Our other plan is $14.50 a month and 25 cents per text message. So we can have $26.50 plus 0.15 T. That's our first plan. I'll highlight that in yellow. And then $14.50 plus 0.25 T, which is our second plan. And of course, we set them equal to each other. Now I have a 0.15 T and a 0.25 T. 0.15 T is smaller and it's positive, so I would subtract it from both sides. That's going to get us $26.50 equals $14.50 plus 0.1 or 0.10 T. Let's get rid of this plus $14.50 by subtracting it from both sides. It's going to get us 12 equals 0.1 or 0.10 T. Divide both sides by 0.1 or 0.10, and we get 120. So that means that 120 text messages would be when the two costs or the two carriers would be the same, or the cost for the two carriers would be the same. And I know you probably send more than 120 text messages just in one day, but this would be when the two carriers would have the same cost. All right, we've got a couple of geometry related questions to finish up with. Let's take a look at those so we can finish up this video. Number 12, the perimeters of the rectangle and the triangle below are equal. Write and solve an equation to find the value of x. So perimeter is the distance around the outside. So let's first find the perimeter of each shape. So for a rectangle, keep in mind that you have two sides of length 6, and you have two sides of length x plus 2. So I did this as follows. I did 2 times the x plus 2, since I have 2 of those, x plus 2 in parentheses, and 2 times 6. 2 times in parentheses x plus 2, when I distribute, 2 times x is 2x, 2 times 2 is 4, and then the 2 times 6 is 12. Now, you could also do x plus 2 plus x plus 2 plus 6 plus 6. Eventually, it will simplify to 2x plus 16. 1x plus 1x, 2 plus 2 is 4, plus 6 is 10, plus 6 is going to be 16. So you end up with 2x plus 16. That's the perimeter of this rectangle. Now our triangle, let's add up all the sides. 6 plus x plus 4, I can drop those parentheses since I'm just adding, plus 2x. I put my x's side by side. I wrote the x as a 1x, so I have 1x plus 2x. My two constants, 6 and 4. That gets me 3x plus 10. I know that the perimeters of these two figures are equal. So I set 2x plus 16 equal to 3x plus 10. Now, 2x is smaller than 3x. It's positive, so let's subtract 2x from both sides. That gets us 16 equals x or 1x plus 10. Subtract 10 from both sides. X is 6. Now, a way to check our solution here would be to find the perimeter of each figure and see if they have the same perimeter. So for this triangle here, if I replace x with 6, then this side right here, 2 times 6 is 12. 6 plus 4 is 10. So the perimeter of this would be 6 plus 10 is 16, plus 12 is 28. For this, I'd have 6 plus 2, which is going to be 8 for this side. 8 for this side, which is 16, plus 6 more is going to get us 22, plus 6 more is a perimeter of 28. So they both have a perimeter of 28 if x is 6. Not saying you have to do that to check, but it is one way to check to see, is my value of x correct? All right, let's finish up with our last example, number 13. The perimeters of the isosceles triangle and the rectangle below are equal. So we need to remember what an isosceles triangle is. Write and solve an equation to find the value of x. If this triangle is an isosceles triangle, it means that it has two congruent sides. So that means this side right here is x plus 3. So we have two sides of length x plus 3 plus another side of length x. That's going to get us, and by the way, the m just represents meters. It's not a separate variable. 2 times x is 2x, 2 times 3 is 6. 2x plus 1x is 3x, so the perimeter of this isosceles triangle is 3x plus 6. And again, I have 1x plus 1x plus 1x is 3x. 3 plus 3 is 6. For a rectangle, we can keep in mind that this side is also going to be 2x minus 2. This side is also going to be x minus 2.5. What I did, though, was I did 2 times the 2x minus 2 plus 2 times the x minus 2.5. That gets me 4x minus 4. 2 times 2x is 4x. 2 times 2 is 4. Plus 2 times x is 2x. And 2 times 2.5 is 5. So I have 2x minus 5. I did add the opposite next, and then I put my like terms side by side. So I have 4x plus 2x plus negative 4 plus negative 5 is 6x plus negative 9. And again, I could just combine all of these together. I've got 2x plus 2x is 4x, plus 1 more is 5, plus 1 more is 6x. Negative 2.5 plus negative 2.5 is negative 5, plus negative 2 is negative 7, plus another negative 2 is negative 9. And again, I want these perimeters to be the same, so I will set them equal to each other. We have 3x plus 6 equals 6x plus negative 9. We've got a 3x and a 6x. The smaller variable expression is 3x, and it's positive, so I'm going to subtract 3x from both sides. That gets us 6 equals 3x plus negative 9. The inverse of adding negative 9 is to add a positive 9 to both sides. That gets us 15 equals 3x. Divide both sides by 3. And that means that x has to equal 5. I can double check to make sure that this value works. So 5 plus 3 is 8. So each side of this isosceles triangle will be 8. This side will be 5. 8 plus 8 is 16 plus 5 is a perimeter of 21. I know it kind of looks chaotic going around here. If I replace x with 5 here, 2 times 5 is 10. 10 minus 2 means this is going to be 8. This side's going to be 8. And then 5 minus 2.5 is 2.5 for each of these. 2.5 plus 2.5 is 5. 5 plus 8 is 13. 13 plus 8 is also a perimeter of 21. So the perimeters will indeed be equal. And because we're doing this here right at the end of the year, at least if you're listening for Math 7, we're not going to have a major test or a ton of practice on this, but this is something that you will see a little bit more of next year. So I think it's good to get this introduction prior to the end of this school year. I do appreciate you listening. Thanks. Have a great evening. Have a great day. Have a great summer.